Welcome, human, to ET's Tutorials. So in this episode, we're going to be learning about SphereCasts and CapsuleCasts. So these might sound a bit odd to you unless you've heard of them before, but basically they are kind of like raycasts, regular raycasts. That's a hard word to say with an S on the end of it. But anyways, it's like a regular raycast, but it's a shape instead of just a line. So in this case, a sphere or a capsule. We're first going to go over how to do it with a sphere, and then we're going to go over how to do it with a capsule. And then at the very end, I'm going to quickly jump into C# and show you the differences in syntax with C#, but the same ideas are going to be the same between C# and JavaScript. So that's what this episode is going to be about. So why don't I go ahead and give you a quick demonstration. So the way that this works is that it looks like, if you haven't seen my previous raycasting tutorials, link in the description below, where I go over basic raycast, raycast all, raycast with layer masks. So if you've seen any of those tutorials, this should all look really familiar to you. So it looks like we are raycasting a line, but we're actually raycasting something that is thicker than a line, and it also has a rounded edge. So you can see as I go around corners, it actually rounds the normal around a corner. So that little cube thing, like if you remember before, it was just snapping to the face because we were just raycasting a single line, whereas now we're basically raycasting a line that's basically expanded to the shape of a sphere that's kind of like stretched out. So that's why it rounds around corners like that. And also before, if you remember, I was able to easily raycast through this because we're only raycasting a line. But because now I'm raycasting a sphere, my sphere is too thick and I can't even get through that thing. Let me try. I can't raycast through that. My SphereCast is too thick. And if I go over here, does this have a big enough opening that I can actually raycast through it? No, that doesn't have a big enough opening either. So that should give you a slight idea of what a SphereCast is. Basically, it's just a really thick raycast. So let's take a look at how to do a SphereCast in code. So this is how to do it in JavaScript, and this one is how to do it in C#. They're both very, very similar. Let me actually go down here and press enter a few times to get it above my head. And then I will also scroll over in case you want to pause the video and read it, or you can just download the zip file, which I will link into MediaFire in the description below. So yes, that is the C# script, and I'm going to go over that in the end, but the same ideas are going to be the same between C# and JavaScript, just slightly different syntax. It's hardly even different at all. Similar script as to the other tutorials in raycasting. Once again, link in the description below to all of the other raycasting tutorials that I just recently did. And the first variable that we're going to save is cube, and this is of type transform, and this is just the cube, which I will zoom in to now, that we are making stick to the surfaces of things. So we're just going to change the transform.position and rotation of that down here if we find a hit using the SphereCast function right here, and then saved inside of the found hit variable right here, which is reset to false at the beginning of every frame inside of the function update loop here, where it says equals false. So we're declaring it and resetting it to false at the beginning of every frame. Actually, I thought in C# we needed to change that to let me just quickly, found hit equals to that. I thought that's how you needed it in C#. I'm not entirely sure. I don't know. Try for yourself, one way or the other. If it's not working, that might be something wrong with it. I don't know. So, anyways. So professional. This is green apple juice, by the way. Don't drink, kids, unless you're 21 or your regional equivalency. So anyways, let me get back to the tutorial. I totally lost my train of thought. I'm dumb. So anyways, let's take a look at the main line of code that we want to talk about. Well, I guess for the SphereCast, the main line of code that we want to talk about in this script. So SphereCast just like a raycast, returns you a true or false variable, and then also can save information inside of a raycast hit variable, which we declared up here, var of type, or var hit of type raycast hit. Ooh, excuse me. That was a bad idea, drinking beer during a tutorial. I'm dumb. So anyways, this is still good information. So it's going to save inside of the hit variable right here. It's going to save information like where in 3D space did the sphere and the actual, like let's say this is a wall or something, and this is our SphereCast. Where our SphereCast is actually going to hit something, it's going to return us the point in 3D space, so that would be hit.point or raycast hit.point. We can also get the normal, so the direction that it is facing, and we use those two variables down here to change the position and rotation of the cube so that we can see where our SphereCast actually hit. So the difference between a SphereCast and a raycast is that a SphereCast, or a raycast, let's start with a raycast. So a raycast, you just give it an origin and a direction. Whereas with a SphereCast, you need to give it an origin, a size, and a direction. Or a radius. You need to give it an origin, a radius, and a direction. So the origin, so this is the center of the sphere at which we are casting, and the origin is transform.position. So in other words, this right here, let me focus in on it. The very tip of our kind of cube gun that we have as a child of the first person camera. And then transform.forward is this blue arrow, so z, +1 on the z axis. So that would be transform.forward. So just so you know, transform.position and transform.forward equals pointing in this direction starting from that point, basically. And then 1 is going to be the radius of the sphere that we are actually going to cast. So it's starting in front of our gun. It's like a sphere, and it has a radius of 1, and then let's say that's forward. Our SphereCast is going to basically stretch out and do that, and it's going to it's just a thick raycast. And then transform.forward is the direction it goes, and then hit, it saves it all inside of hit. And we can also give it a distance if we want to. Like, let's say we want it to only have a distance of 100 or something like that. We could just put 100 right there, and that would give us the distance. So that is, well, I just demonstrated it a second ago, but I might as well play it one more time. That is a SphereCast, which, as you can see, cannot go through that hole because it is a thick raycast. So it's too thick to fit through that hole. All right. So now let's talk about a CapsuleCast. So I'm going to comment out that line of code, uncomment that one to bring it back into play. So we're going to do a CapsuleCast as we have right there. So physics.CapsuleCast. Oh, by the way, with SphereCast, actually I'm not entirely sure about CapsuleCast. I would assume you can do it with CapsuleCast, but you just write the word all afterwards. So just like that, SphereCast all, and then it becomes just like raycast all, and you would handle it the exact same way as a raycast all function using an array and all of that. Link in the description below to a tutorial on how to do a raycast all. Basically, if you just replace the word ray with sphere, basically that tutorial will cover how to do a raycast all. Okay, so let's move on to a CapsuleCast. So physics.CapsuleCast. So a CapsuleCast basically is just like a SphereCast, except instead of starting with a sphere, we're starting with a capsule, which we can actually rotate and stretch and make any kind of shape that we want, as long as it's still a capsule. So the way that we're going to construct a capsule in this scenario is we're actually going to kind of tell Unity two spheres that we want, and then it's going to kind of like connect the two of them into a capsule. So if you ever notice a capsule, it looks like the top and the bottom of it are two halves of a sphere, and then it has a cylinder going between the two. So we're going to basically define those two half spheres, or we're basically just going to call them whole spheres in this situation. So just like before with the SphereCast, where we determined like an origin and a radius to determine the sphere, we're going to determine the origin of two different spheres and then a radius and then a direction that we want it to capsule cast from. So let's say the direction we want to capsule cast is in that direction. We have a sphere here that we determine, a sphere here, and then they turn into a capsule. And because we're capsule casting in that direction, it's going to go like that. So it's kind of hard to imagine, but it's kind of like a SphereCast except taller, basically, or wider, or whatever direction you want to rotate it. So in this particular situation, we're going to start with the center of our body, and we're going to create a capsule cast that basically goes halfway up this way, so a sphere here, and then a capsule that goes halfway down right here, and then that's going to be our capsule, and then we're going to cast forward from there. So the first parameter that we give it is a vector3 to determine the first sphere. So we have transform.position plus transform.up times 5, or 0.5. So transform.position, this is the position of our raycaster, so the game object that this script is attached to. And then we're adding transform.up. So this is a directional vector3 with a magnitude of 1 that is basically pointing up, like the up direction from our transform, depending on how our transform is rotated. And then we're going to multiply that by 0.5 so that we don't go up too high, because we want it to float somewhere around our head is basically where we're aiming at. So basically all of this right here will give us a vector3 that should hopefully float like up at head level. Now we want to make a sphere that basically floats at feet level. So we're going to do transform.position plus transform.up times negative 0.5. So just like before where it went up 0.5, we're just multiplying it by negative 0.5. So instead of up, it would be like transform.down, which I don't think transform.down is an actual variable that you have available to you. Correct me if I'm wrong, but I'm pretty sure just I know negative up is what down would be, but I don't know if down is actually available to you. So basically we're multiplying transform.up by negative 0.5, and that's going to make a sphere that basically floats somewhere around our feet. So the first parameter of the CapsuleCast function is sphere1, the second parameter is sphere2, and the third parameter is the radius of those two spheres. And as you can see in this situation, I have it set to 0.2 because I want it to be a really, really skinny capsule to demonstrate how you can go through like tall situations where you have like two walls like this and you want to like capsule cast through that for things such as AI and path navigation and things along those lines. So the next parameter is the direction of the capsule cast. Whoops, let me highlight that. It's not forward. There we go. That's what I wanted to highlight. There we go. Okay. All right, so we have transform.forward. So this is a directional vector3 with a magnitude of 1 pointing in the forward z direction of the game object that this script is attached to. So basically we're just saying what direction the capsule is going to shoot. So we determined our capsule, and then we're just going to, that shape that we have, we're just going to stretch it through space, and we're going to detect for collisions. And transform.forward, so the fourth parameter inside of this function is just determining the direction of the capsule cast. And then we have hit, which is the raycast hit variable, which we determined up here. So just hit, just like that. The fifth parameter will save us like the point and normal of the raycast hit, and it will also save us the transform and the rigid body and the collider and the distance and all of those cool things. And then just like SphereCast and raycast, CapsuleCast returns true or false depending on whether or not it actually made a collision with anything. And so we're saving that inside of this variable right here, found hit, which we reset to false at the beginning of every frame. So if we find a hit, found hit will then equal true. So if found hit equals true, then we're going to update the position and have it match hit.point. So hit, the hit information inside of the raycast hit variable up here, or hit of type raycast hit, and then saved from here inside of the CapsuleCast function. We're going to update the position with hit.point at which the CapsuleCast actually collided with something, and then we're going to change the rotation quaternion or our cube.rotation, because cube is of type transform. Cube.rotation is a quaternion, and hit.normal is the direction at which the face that we hit is facing. And that is a vector 3, so we use quaternion.lookRotation to convert that into a quaternion so that we can then update cube.rotation. So now when I play the game, let me go ahead and hit run. Now when I play the game, I can shoot. I can also, just like before, kind of make it around itself, around corners. And I can't shoot through there, as you can see. It's just my CapsuleCast is too tall to fit through that hole, but I can fit through here because it's a skinny, tall capsule, and I can fit through this narrow hole, but I can't fit through here. And I might be able to fit through here too. No, never mind, I can't. I can only fit through this one. So that is a CapsuleCast and how a CapsuleCast works. Now let me go ahead and jump into the C# script just to show you the very slight differences. And the only real difference, I mean, just like you probably will predict this if you watched all of the other raycasting tutorials, but you just need to write out in front of hit so that it knows. Let me highlight that actually so you can see it. You need to write out in front of hit so that it actually knows that it's sending information out to that variable. And then same down here with the CapsuleCast, you need to write out hit. Whoops. Let me select that one more time. Out hit right there, just like that. That's the line of code that I had commented out. Whoops. So just like that, and then just showing you what I did with the JavaScript. And then I already showed you the Boolean and resetting it to false every frame. And then inside of, or when we're declaring the hit variable of type raycast, we need to create a new blank raycast hit variable to save inside of the variable hit, because we can't just have it be totally blank. We have to have it be like actually we need it to be a raycast hit variable with new information that doesn't actually mean anything. So it's not actually blank. It just has information in it that doesn't actually pertain to anything because we just created new default information. So I think pretty much everything is going to be set to 0 and null if we were to try to pull information out before doing a physics.SphereCast or CapsuleCast or raycast all, or whatever you want to do to get a raycast hit variable. So yeah, that's all the differences between JavaScript and C#. And hopefully that should be pretty much going over everything that you need to know on how to do SphereCasts and CapsuleCasts. And once again, link in the description below to a raycast all tutorial. All of the information will be pretty much exactly the same when it comes to doing a SphereCast all. The only difference is you just got to replace the word ray with sphere, and basically it's all of the exact same information. So hopefully you found this helpful, and I guess until my next episode, I will see you later and keep making games.